Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to identify direct variations and find the constant of variation. Alright, the instructions for the examples that we're going to be working on is as follows. We are to find a constant of variation for the given direct variations. Okay? Question number 1. Let's say we have a direct variation presented in a numerical format as a set of ordered pairs. So let's say we have 1, 4, 2, 8, and 3, 12. Alright, so first of all, how do we know for a certainty that this is a direct variation? All direct variations presented as ordered pairs have a unique relationship between the x and the y coordinates. So if you look at the x and the y coordinates for each pair, so from 1 to 4, and 2 to 8, and 3 to 12, by inspection you notice that something happens. From 1 to 4, you multiply by 4. From 2 to 8, you multiply by 4. From 3 to 12, you multiply by 4. So when going from x to y, if you're multiplying the same constant every single time, that represents a direct variation. Okay? And by inspection, the constant of variation is that number that we multiply by every time. Okay? So by inspection, we can arrive at the conclusion that k is equal to 4. All right? Now let's find the constant of variation using the formula. All right? So the formula that relates the x and y coordinates of a direct variation is given by k equals y over x. So what we can do here is we can pick any ordered pair and divide y and x, and that will give us what the constant of variation is. Okay? So let's take a look at, use the first coordinate for this calculation. So k is going to be the y coordinate there is 4 divided by, change the colors. The y coordinate is 4 divided by the x coordinate, which is 1. 4 divided by 1 is 4. Okay? So for question number 1, the constant of variation represented by the letter k is equal to 4. Okay? All right, let's take a look at another example. Let's say we have another numerical representation in ordered pair format. 5, 1, 10, 2, and 15, 3. All right, so let's study this direct variation and see if we can confirm that it's a direct variation just by inspection. Okay? So let's look at what we can do to go from the x to the y. Do we multiply by a constant? That's the question. So 5 to 1, what do you multiply 5 by to get 1? That's the question. So if you think about it, 5 divided by 3, 5 divided by 5 divided by 5 is 1, right? But can we write this division operation using multiplication? Absolutely. So the divisor, if we write it as a fraction, we can drop, change, flip, right? Drop the dividend, change it to a times, and you flip the divisor, 1 over 5. So to divide by 5 is the same thing as to multiply by 1/5. So is that the case with every single x and y pair in here? 5 times 1/5, or divided by 5, is 1. 10 times 1/5, or 10 divided by 5, is 2. 15 times 1/5, or 15 divided by 5, is 3. Okay? So we see that we're multiplying by the same constant every single time. All right? So by inspection, we can arrive at the conclusion that our constant of variation is 1 over 5, the number that we multiply by every time. Okay, so how about using the formula? If we want to use the formula, let's go ahead and write down what the formula is for direct variation. The formula is given by k, the constant of variation, equals y divided by x. If we make the substitution, we're going to have k equals, you can pick any ordered pair that you want, okay? So let's pick the second one, for example. Y is 2, x is 10. Can we reduce this? Absolutely. The greatest common factor of 2 and 10 is 2, so we can divide both by 2, top and bottom. And then upon reduction, we're going to have 1 over 5. Ladies and gentlemen, our constant of variation, or k, let's write it down. Constant of variation given by the alphabet k is 1 over 5. All right, now let's take a look at another problem, number 3. Let's say in this case we are given a numerical representation presented in a tabular format. Okay, so let's consider this table right here. Okay, so these are my x's and y's. So for my x, I have 5, 6, 7. And then for my y's, I have 15, 18, and 21. Now, how do we know for a certainty that this table represents a direct variation? What we can do is examine the x and the y's, and we'll ask ourselves, are we always multiplying by the same number to go from the x coordinate to the y coordinate? 5 times what gives you 15? Times 3, right? How about 6 to 18? Times 3 again. 7 to 21? Times 3. So since we're multiplying by the same number every single time, we can easily conclude that this is a direct variation. Okay, so by inspection, we can see what the constant of variation is, which is 3. All right, how about if we use the formula? Using the formula, the same formula that we've used multiple times, the formula is k equals y over x. We can calculate what the constant of variation is. So let's use it first. You can use the first, second, or third pair. It doesn't really matter. Okay. So let's use the first one. K equals y, which is 15, over x, 5. What is 15 over 5? It's 3. Okay. So our constant of variation given by the letter k is 3. All right, let's take a look at question number 4. So for question 4, we're going to be looking at the algebraic representation of a direct variation. So y equals 3x. So how do we know that this is a direct variation? It's a direct variation simply because it is of the form y equals 3x is of the form what? Is of the form y equals kx. Any function that's of the form y equals kx is automatically a direct variation. So let me show you an example of something that's not. Let's say you have y equals 2x plus 4. This is not a direct variation because you're adding on 4 there. Okay? So you always have y equals kx. One term on the left, one term on the right. On the left you have y, on the right you have a constant multiplied by x. All right, so since this is of the form y equals kx, can we identify what the constant of variation is? The constant of variation is simply the coefficient of x. Okay, so we can see that k in this example is 3. All right, so the constant of variation given by the letter k is 3. Let's take a look at another algebraic example. Let's say we have 3y equals 5x. Now you might look at this and say, oh no, this is not a direct variation, but it's because it's not of the form y equals kx. But the question is, by algebraic procedures, can we convert this? Can we transform this equation into a y equals kx format? The answer is yes, we can. How do we accomplish that? Simply isolate y, okay? So if we divide both sides by 3, we're going to have y equals 5 over 3x. This is a constant, a direct variation because it's of the form y equals kx. Okay? So let's write down the formula underneath. Y equals kx. Can you see what the constant of variation is here? It's the coefficient of x. Okay, so k in this problem is just 5/3. Alrighty, so our constant of variation for number 5, constant of variation given by the alphabet k is 5 over 3. Alright, lastly, we're going to take a look at a graphical representation. Alright, so for question number 6, let's consider this graph right here and see if it's the graph of a direct variation. Okay, so there goes my x and y coordinate. And let's say that we have the line going through the origin, and it goes through. So you have a line like this. All right. So, question, is this graph the graph of a direct variation? What do you think? This is a graph of a direct variation. The answer is yes. Now, how do we know that is the graph of a direct variation? Well, there are two things that need to be present to enable us to arrive at that conclusion. And the first thing is the line has to be slanted. Okay? So component 1, you need a slanted line. And component 2, it has to go through the origin. Okay? So if you have a slanted line that goes through the origin, then it's automatically a direct variation. All right? What's the origin? The origin is the point 0, 0. The point where the x and y axis intersect. So there goes your origin right there. Okay? Now, in this particular case, we see that it goes through the origin. There goes the origin right there. The line goes to the origin, and the line is slanted. So check, check. This is a direct variation. All right, so now let's go ahead and find our k. To find our k here, all we just need to do is find a point on the graph. So this point right here, 1, 2. We have a point on the graph, so we have the point 1, 2. This is our x coordinate and our y coordinate. And then we'll use the formula k equals y over x to finish it off. Okay, so k is y, which is 2 over x1, and that's 2. So in this problem, the constant of variation for this direct variation is k equals 2. Okay, so that's how to identify direct variations and find the constant of variation. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of direct variation, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other tutorials. We upload videos to our page regularly, so do subscribe so you can get updates. If you have any questions or comments about what we covered in this presentation, just post it in the comment section below, and we will be more than glad to assist you. A lot of support resources can be found at our website, mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.